Rational exponents. So remember we talked a lot about roots and radicals and how there can be different roots, little numbers there to indicate the root, right? It could be the third root, the fourth root, the fifth root, and so on and so forth. And what does that number tell me? That's exactly right. How many times that number is multiplied? I could put, so if I put an n there, this tells me that x is multiplied n number of times, right? Or this value is multiplied n number of times. Give me this. So this is the number of times it's multiplied. What if there's not a number there? It's 2. Because it's a square root. That's the implied. And that is times itself twice, and that's the one you're used to. So now I'm going to complicate it just a little bit. Every root can be written as an exponent. Now I've got rational exponent. What's it mean to be a rational number? Rational can be written as a fraction. That's exactly right. I'm talking about fractions here. And I know y'all love fractions.
Everyone's favorite expert.
Was that this class?
No.
That was last semester. All right, so how do we do that? Let me show you. Whatever this root is out here, it becomes, and remember there's an implied 1 here as well, right? It becomes a fraction as an exponent, okay? And that root is the denominator of the fraction. So if I had the square root of 16, and just take out your calculator for just a second because I'm going to show you that. This would be 16 to the what power? 1 over 2, because there's an implied 2. So take out your calculator. We know that the square root of 16 is what? 4. So take out your calculator and do 16 raised to the 1/2. And when you do it, you're going to need to do parentheses around the 1/2 because every fraction goes in parentheses. And make sure you still get 4 so you believe me, I'm not telling a story. Do 16 raised to the 1 divided by 2. It looks like 4. That's exactly right. All right. What happens if there is already, let's say there's an exponent here. So let's say I have the third root of 5 to the 2nd power. I call this radical form. And I can change it to exponential form, rational exponential form, that is. No, I'm sure. Irrational cannot be written as a fraction.
Are you sure?
So what does the exponent become here? The base is 5. What's the exponent? That's right. 2 over 3.
Wow. Good job, Summer.
That's right. This is always the denominator. This is always the numerator. It could also be written this way. This is still 5 to the 2/3. Everybody with me? Everybody okay?
To the window.
So, back when I taught this has been a long time ago.
A long time.
I had a kid who was from Brazil, and he had already learned this, and he said, "Oh, that's not the way we learned it in Brazil." And he showed us this really cool way, and I don't know why it is stuck in my head. It's the silliest little thing, but it really, really, really helps you remember it. He said, "We call these sunshine problems." Sunshine problems. He's like, "Can I come show the class?" And I was like, "Sure." And so he said, "Envision the sunshine sitting above the problem." This is going to be really stupid, y'all, but it's going to help you remember it. He was very smart.
I have a question. Do you speak English? Good? Do you speak Brazilian? Portuguese?
I don't speak anything but English, so I don't know. I didn't speak anything.
Did you ever hear him talk in other languages?
Okay. If I'm in radical form, watch how silly this is. If I'm in radical form, the 3 is outside getting all the sun, and the 2 is sitting in the shade, right? So when they change forms, they change spots. The 2 goes in the sunshine, and the 3 stays in the shade. That's just the way it works. You'll always, and it sounds silly, but you'll get confused. Which one goes on the bottom again? Which one goes on the bottom? So if he's in the sun to start with, then he's in the shade when you switch it. 100% Logan. I know. When you get a little more advanced, you would, but it's still easy if you had 5 to the 1/2 and you've got the, let's say, the cube root. Well, then this is just, what I could really do is just write this way. So it'd be 5 to the 1/6. You won't have anything like that just yet. Let's practice changing some forms.
Yippee!
And let's do some simplification with it too. Let's do this one. 7, 12w to the 1/2. Change the form and simplify. So if I change the form, and changing form is going to be the key to getting through the rest of this unit, because the quicker and the easier you can do it, the easier the problems are to do. The answer kind of pops out at you whenever you're able to change the form. So looking at this one, how might I write it in radical form? Not everybody all at once now.
17.
Simmer down.
84 W's 217.
This means what as a radical? As a radical, though. It's a square root. You're exactly right. So now I have 7 times the square root of 12w. Yes? Can I simplify that any? There's a 2 outside. Can you simplify this? 4 and 3. So I get 7 times. I'm going to break this up, 4 and 3, right? So it becomes 2. So I get 14 times the square root of. Hank, contain your excitement, please. You always want to break down and simplify if you can. That's your final answer. Let's do another. Do an exponential form. Write an exponential form. What's the base? K. What's the exponent? 7 over 4. That's exactly right. The 7 was in the shade, so put it in the sun this time. Does that make sense? Simplify and change the form.
Come on, you know you're cooking still. Okay. Everything's good.
What? All right, simplify first. What do you do? No. 2 goes into 5 how many times? This is not right. 2 goes into 5 twice. How many are left? 1. 2 goes into 3 one time with 1 left, and then I've got the B. Now change the form. Okay, where are you confused?
I know it's 2 and 5, but like, why like 10 to a?
Well, 2 here goes into this. 2 goes into 5 twice. So I can do it this way. But if I'm not simplifying radicals themselves, I could also, and this would also be acceptable, I could do 10 to the 5 over 2, A to the 3 over 2, and B to the 1/2. Right? Because this just becomes an exponent of 1/2, and it goes to everybody inside since I'm multiplying.
Why don't we just?
So either one of those is okay. Uh-huh.
Why don't we do that for like
2 and 5.
yeah, like 10?
Well, so really, 10 to the 5th is really, and so I did break it. I did. Either one. It depends on what's being asked. So for this one, let's see, it's just exponential form, so you wouldn't have to simplify it first, but they're both exponential form. And they give you the same thing. We'll make it easy. We'll stick with that one. Yes, no, maybe so. This one's a maybe. Let's do another one. Nine x 7y4. No. Simplify that one. Go. Don't worry about simplifying the radical like we did. Just put it in exponential form. Because that's really what I'm going to practice with today. Because that's the new stuff. Oh, every day. Yes. Yes. All right, what'd y'all get? 9 to the 1/3. Easy? Yep. All right, let's crank it up then. As we do these, all of the exponent rules that we already learned are going to apply to what we're doing now. So it doesn't matter. Remember those 7 exponent rules? Do I need to review those? Yes. All right, 1, remember if you are multiplying with the same base, You add the exponents. Dividing with the same base, what do? Subtract them. And here, we've only done whole numbers before, but it doesn't matter if it's a whole number or a fraction, it still stays. It still stands. The property does. How about if you have a power raised to a power? What do? You multiply. If you are multiplying in the parentheses, you can distribute that exponent. When else can you distribute the exponent? What? Not if you, no, not FOIL. If you're dividing. Multiply or divide in the parentheses, you can distribute the exponent, right? Addition or subtraction, you'd have to multiply it out. You'd have to FOIL it. What are we missing? Negative exponent, what happens? It flips. 1 over, and it turns positive. That's exactly right. Very last one is just that zero exponent property. Anything to the 0 power is 1 as long as the base is not 0 itself. Remember them now? I'll give you a second. Some of you are copying them down. Okay.
Please, I will be quiet. You should not hear me.
No. Charlie can just, that's fine. All right. Let's do a couple examples. Look at number 19. Let's do these together. All right, what am I doing on the first one? The bases are the same, so what do? You add them. You add them. So we're going to have to go back and remember not properties, but how to add and subtract fractions, right? Y'all know how to do that on your calculator. We're looking at number 19. Okay, if you do not remember, take out your calculator right now and let me walk you through doing it on your calculator, because some of us, remember, they have to have common denominators to add or subtract. This one does, so that's good, but just in case you don't remember, you'll want to do a parenthesis and then 1 divided by 3 plus parenthesis 4 divided by, whoa, how did that even happen? You got 4 I'm telling you, all this because we don't have a printer. All right, so if you do this, right, it gives you some number. Then you want to do math, enter, enter. It's going to put you back into a fraction, okay? When you do this, you should get 5/3, yes? Make sure you get 5/3 on your calculator. You do this with any operations, just make sure that you put your fractions in parentheses here. I'm doing the right operation. So I get x to the 5/3. Is everybody okay there?
No.
Okay. All right. How about number 20? Again, because I'm multiplying with the same base. Oh, it says, look what it says. Right answer is a radical in simplest form. So let's not move to 20 yet. What's this look like as a radical? What's the root? The cubed root of x to the 5th. Is that simplest form? No. 3 goes into 5 how many times? Once. And what's left? Huh. 2.
Dang it. Always get it wrong.
3 goes into 5 once and leaves me 2 left over. All right, look at number 20. Try number 20. For which one? Yes, since they were the same base, we added them together. Same thing with 20. Same base to add them together. What do you get? 1/4 plus 3 halves. 7 over 4. Yep. Now radical form. What's the root? 4th root of p to the 7th. Is that simplest form? No. 4 goes into 7 once with how many left over? 3. How about 21?
Can you do some for me?
I'm dividing. Dividing means do what with the exponents? Subtract them. So what's 5 over 2 minus 7 over 4? 3 over 4? 10 minus 7, yeah, it is. Yes. Write it in radical form. 4th root m to the 3rd.
There's no way that's how you do it. That's gotta be wrong.
How about 22? What's the property? Multiply. When you multiply fractions, it's top times top, bottom times bottom, yes? So you may not even need your calculator for this. You get, when you multiply fractions, it's top times top, bottom times bottom. So it's a to the 5 over 6. So these are getting pretty easy for us, yes? Just a couple more to make sure. Y'all got that before I exit. We did one like that. How about here? How about 24? What's going on?
A little bit of math.
What do I do?
You gotta multiply.
Okay, but you got to do something else too. It goes to both pieces, right? And then I would multiply. You're exactly right. So I get 8 to the 2/3, x to the 4/3, right? Now look what's going on here. Everybody's over 3, right? So everybody is a 3rd root. 8 squared x to the 4th, and now I need to simplify. This is where it starts getting a little harder. 8 squared is 64, yes? So what's the cubed root of 64? 4. 3 goes into 4 how many times? 1, and how many's left? That's the answer.
Take off on the gas on me. I'm kind of lost once we broke out.
So you're talking about whenever I went from here to here. All right, so here, because they both have the same denominator, they're both over 3. That's why I put the third root here. Okay, and then Logan, go sit down. Then I put the 8 squared and the x4 inside, right? Well, 8 squared is 64, and the third root of 64 is 4. Yeah.
I made a 90, and all of a sudden I got it from a 71 to 72.
It's only a 20-point quiz.
See, when I went to 50 on the quiz, then it dropped down like 30 points.
You want me to put it in and show you it's not going to drop at 30 points? It's not possible. Yeah, you can, Charlie. Put it in there. You can play around with those and see what it does. All right, what's the negative exponent do? Look at 25. Flips it, right? So I've got 1 over 100 to the 1/2, or 1 over the square root of 100. Yes? What's the square root of 100? What if I'd have gotten a radical on the bottom whenever I'd done that? That's exactly right. You'd have to multiply by that. If I ended up with 2 over the square root of 5, remember I have to get that square root out of the bottom. So all those rules we already learned still apply. I'm almost done, promise.
Dude, I'm like Spider-Man.
Let's do a couple of these radical ones. Look at 30. Simplest radical form. Can I just put these two under the same radical? Why? They're not the same root. One's a fourth root, one's a square root. So instead, I'm going to change them to exponential form. So it becomes r to the what? 3 over 4 times r to the 1/2. Now, because I'm multiplying and the base is the same, what can I do with those exponents? Add them.
The base is literally not the
It's not, but I can do it on the calculator or find common denominators. The base, the denominator of the fractions is what. So 3/4 plus 2/4 would give me. Or you could have done it on your calculator, but that's not simplified form, right? It's a simplified radical form. So now I do the fourth root of r to the 5th. Is that simplified? Still not simplified, because 4 goes into 5 how many times? And how many are left? Now I'm done. Okay. Same thing with all of these here. You would change it to rational exponent form and subtract. Simplify here. Or y'all, I don't want to bore y'all to death. Some of y'all look like you're bored to tears. Think you can do it? Changing forms is key. That's key. All right. Let me tell you what I want